This phrase sets the stage. I'm exploring how to make sure I get the same results every time I use scikit-learn's traintestsplit function to divide my data. That's key for reliable machine learning. This tells me I'll be choosing the correct answers from a list of options. I like multiple choice questions. They're a fun way to test my understanding. I am using the traintestsplit function in scikit-learn, a popular Python library for machine learning, to split my dataset, which contains 100 samples, into training and testing sets. The goal is to select the options that guarantee I get the same split each time I run my code. That's about reproducibility. This is an argument to the traintestsplit function. Setting randomstate to a specific number, like 42 here, acts like a seed for a random number generator. It ensures that the data is shuffled in the same way each time, leading to a consistent split. This is super important for reproducibility. This argument determines the proportion of the data that will go into the test set, 20% in this case. It doesn't directly control the random process of splitting, so it doesn't guarantee the same split every time. This argument is used for stratified sampling. If I set it to my target variable y, the traintestsplit function ensures that the class proportions, the ratio of different categories in y, will be similar in both training and testing sets. On its own, it won't guarantee an identical split each time, but combined with a fixed randomstate, it makes the stratified split reproducible. This argument determines if the data is shuffled before splitting. If it is true, and it is by default, and I don't set randomstate, then the shuffle will be different each time I run the code, resulting in different splits. This simply states that I have a dataset with 100 data points. This signifies that I've reviewed all the necessary details and now need to answer the multiple choice question. This question focuses on how to make sure you get the same data split every time you run sklearn traintestsplit function. It's about controlling randomness to get consistent results. This is the core question. I'm asking which settings in the traintestsplit function ensure that the data is divided into training and testing sets in exactly the same way each time you run the code. We have a dataset with 100 data points. I need to split this dataset into training and testing sets, and I want to make sure that I always get the same division of data each time. This is the sklearn function I'm using to split my data. Understanding its parameters is key to answering the question. This is the portion of my data I'll use to teach my model. I want to make sure I use a consistent portion of data for this training. This is the portion of my data I'll use to evaluate my trained model. I want this test data to remain consistent for accurate and repeatable evaluation. I want a train test split that gives me the same result every time I run my code. This is crucial for reliable experiments. Scikit-learn's train_test_split function helps me achieve this. I have 100 data points. I'll split these into training and testing sets. This is the scikit-learn function I'll use. It splits my data into training and testing sets. It takes several arguments that control how this split is performed. I'm setting this argument to a specific number, 42. This sets the seed for the random number generator. Think of it like setting the starting point of a random number sequence. This ensures I always get the same, random, split. This argument decides what fraction of my data goes to the testing set. Here, 20% of my data goes to testing, the remaining 80% is training. It doesn't guarantee the same split each time, it just defines the size of the test set. This is really useful when I have labeled data. I want my training and testing sets to have a similar mix of my labels, e.g., if I'm classifying cats and dogs, I want a similar proportion of cats and dogs in both. This helps me avoid biased results. However, it alone doesn't guarantee the same split every time. This shuffles my data before splitting. This is generally a good idea to avoid bias, but without a _random_state the shuffle will be different each time I run my code and I won't get a consistent split. The portion of my data I'll use to train my machine learning model. The portion of my data that I use to evaluate how well my trained model generalizes to new, unseen data. I have a dataset with 100 samples. This is the total number of data points I'll split into training and testing sets. I'm learning how to reliably split data using scikit-learn's _train_test_split function. Reliable splitting means getting the same split every time I run my code. That's crucial for getting consistent results and comparing different models fairly. I need to identify the _train_test_split function arguments that guarantee the same data split each time I run my code. This is like a detective case. I want to find which arguments are the clues that make it reproducible. Setting _random_state to a number, like 42, is like giving the random number generator a specific starting point. Think of it as setting the seed for the random numbers used to split the data. Every time I use the same seed, I get the same shuffle and the same split. This argument specifies the fraction of the data to use for testing. For example, 0.2 means 20% of my data will be used for testing and 80% for training. This alone doesn't control the specific data points that go into the test and training sets. It only determines the proportion of samples. The _stratify parameter keeps the proportion of different classes in my target variable, represented here by y, consistent in both the training and testing sets. This is helpful for balanced datasets. But it's important to note, _stratify does not guarantee the same split across runs unless I also set _random_state . The _shuffle parameter determines if I shuffle the data before splitting. Usually, I want a random shuffle to avoid bias. However, without _random_state , a different random shuffle will occur each time I run the code, resulting in different splits. I'm using scikit-learn's _train_test_split function to divide my dataset. I want to make sure that I get the same training and testing sets every time I run my code. This is important for reliable results. Setting _random_state to a specific number, like 42, is crucial. This acts like a seed for the random number generator. Think of it like setting the starting point for a random process. The same starting point always produces the same outcome. This guarantees the same split each time. This argument only controls the size of the test set, 20% in this case. I'm only setting the proportion of data, not the specific data points themselves. So, it doesn't help me get the same split every time. It just tells me how big the test set needs to be. Stratifying, using the target variable y ensures that both my training and testing sets have similar class distributions as my original dataset. It doesn't guarantee the exact same split, but combined with _random_state , it would produce a reproducible stratified split. This shuffles the data before splitting. Without _random_state , this shuffling will be different each time, leading to different splits. Even though I want to shuffle my data, I need _random_state for reproducibility. This question asks which scikit-learn _train_test_split function arguments ensure you get the same data split every time you run your code. I'm looking for the arguments that eliminate randomness in the splitting process. Setting _random_state to a specific number, like 42, acts like a seed for the random number generator. Think of it like setting the starting point for a random process. It makes the seemingly random process predictable. This is the key to reproducible splits. It guarantees you'll always get the same split. The _stratify argument ensures that the proportion of different categories in your target variable, y is maintained in both your training and testing sets. For example, if your target variable has 60% positive examples and 40% negative examples, it keeps that ratio in both parts of the split. While it doesn't directly control the randomness of the split selection, it becomes reproducible when used with _random_state . The _shuffle argument determines whether your data is shuffled before being split. If this is true, the default, and _random_state isn't set, your split will change every time you run your code because the shuffling is random. To get consistent results, I need to control that randomness with _random_state . This just tells me the size of the dataset. It doesn't directly influence how I should pick my arguments for reproducible splits, but it's good context to keep in mind. This just determines the size of the test split, 20% in this case. It doesn't guarantee the same split every time, only the proportion. It's independent of the reproducibility aspect.